After we have investigated the performance of various protocols, especially in LAN environments, we must also give it a thought that there are certain residential users who are using internet. What kind of technology are these users using? Think about your own internet connectivity at your home. Are you using a cable modem? If you are, then this is the most appropriate and relevant module to start thinking about modeling and simulating such a network. We call it packet cable network that provides you internet service using a cable modem in your household. We shall understand the background for cable modem networks. We'd look at the components, the entities including the headend and CMTS, and finally, we'd quickly look at how the cable modem works. The primary motivation for packet broadband cable network is based on the fact that cable TV coaxial cables have long been available to the residential subscribers who have been using cable. After the availability of fiber optic and its coexistence with the coaxial cable, the hybrid coax networks have evolved. This uses amplifier technology, so using new amplification, which is either in the electrical domain or in the optical domain, longer distances can now be achieved. This HFC is the base for the packet cable networks. This packet cable network is considered to be an alternative and a competitor to the digital subscriber line, which is yet another form of internet access which is given to the residential customers. The primary architecture for packet cable networks comprises a tree topology. As you can expect, in the tree we have the root node, and then we have subsequent children nodes. And these children nodes are actually the residential users, and the root node is the head end. Typically speaking, now since the packet cable network involves the satellite, so it was considered to be a one-way technology in which there was just one broadcast coming from the satellite to the residential customers. However, with the internet service and the data communication service now being provisioned on these coaxial cables, new devices have been evolved, and these include the headend and cable modems. Headend is actually an operational center of cable TV. It is connected to the distribution nodes through trunk cables. These trunk cables are the coaxial cables or fiber, and then we also have these feeder cables which are connected to the cable modems of the residential users. This is what we expect the overall picture to be. The satellite has always been used to provide satellite channels such as various infotainment channels, which are sent to the cable TV headend. The cable TV headend sends it through the distribution hub to the HFC hybrid coax medium, and from there down to individual households. But since we are interested in using this infrastructure for now data transmission, we can imagine that we need to have installed some distribution hub that either takes satellite channels from here or the internet traffic from here. And then we have CMTS, that is cable modem termination system, another entity which is connected in this distribution hub and CMTS unit, which is now connected to the same HFC. So either the satellite channels are being sent to the individual users or the internet traffic is coming in here. So we have successfully demonstrated that using the hybrid fiber coax, the conventional cable TV can now be used for internet traffic as well. The headend now has some evolved functionality. That is, although it was always being used to receive broadcast signals from satellite and microwave, and then it would mix it with local TV programs. then the only job of primary head end was to assign channel frequencies to all signals destined for cable distribution. With the emergence of internet traffic here in this whole scenario, the job of the head end has now evolved. It has evolved with the help of CMTS. CMTS actually controls the bandwidth allocation for data traffic to each of these modems which are within the residential households. The CMTS is the entity that assigns the bandwidth depending upon the user requirement, and it also assigns each cable modem a time slot so that individual streams can be uploaded to the CMTS and subsequently onto the internet. CMTS also enforces QoS policies for traffic shaping and policing. Since CMTS is assigning bandwidth on the basis of user demands, there is a kind of competition. And because of that, as the number of users grow, the overall performance of packet cable networks reduces. And that is why we see that DSL turns out to be a winner in this case. But regardless of that, packet cable networks are still a widely adopted standard. The cable modem within the household has to be configured on the basis of a standard which is called DOCSIS, Data over Cable Service Interface Specifications. So we see that now your house is going to include the coaxial cable coming into your household. Then we have a splitter. This splitter either gives the satellite channels coming from the satellite to the head end and down to your house to the set-top box, and you can see the TV channels here. The data traffic that enters here now goes into this modem. This modem includes a tuner that tunes in to the right frequency, demodulates the data, and gives it to the personal computer. Now you see that here it includes the medium access control sublayer, because since cable modem is based on the shared medium and bandwidth allocation on user demand, so some kind of medium access policy has to be there. And then you can connect your PC directly, or you can have an Ethernet hub and you can connect as many PCs as you like.